Good morning, children. Today we are going to start a new chapter, chapter number 10, Circles. We have come across many objects in our daily life which are round in shape. Here we are going to study about circles and its related terms and the properties of a circle. So in introduction, let us see what is a circle. The collection of all points in a plane which are at a fixed distance from a fixed point in the plane is called a circle. The fixed point is called the center of the circle and the fixed distance is called radius of the circle. We can see diameter of a circle is a line segment that passes through the center of the circle and whose endpoints lie on the circle. A chord of a circle is a line segment whose endpoints lie on the circle. From the figure we can see O is the center of the circle, OE is the line segment from the center to the circle which is called as radius, AB is the diameter since the endpoints are on the circle and it passes through the center. CD is the chord where the endpoints lie on the circle. Another term related to circle is called an arc. We can see a piece of circle between two points is called an arc. The length of the complete circle is called its circumference. So we can see when we take 2 points on the circle, we get a small piece as well as a big piece which we call as minor arc and major arc. Minor arc is usually named with 2 letters and we call it as minor arc AB. When it comes to the big one, we call it as major arc and is usually represented using 3 letters arc ACB. In class 9, we will see 2 new terms of a circle. The first one is called a segment, the other one is a sector. So, what is a segment? The region between a chord and its associated arc is called a segment. In this figure, we will be able to see 2 types of segments, which are the major segment and the minor segment. We can see a circle with a center O and a chord BC. So, while drawing a chord BC, the circular region is divided into 2 parts. One is the minor segment and the other one is the major segment. Sector. A sector is the part of a circle enclosed by 2 radii of a circle and their intercepted arc. Like segments, we can find the minor arc corresponds to the minor sector and the major arc corresponds to the major sector. The region OPQ is the minor sector and the remaining part of the circular region is called the major sector. So, we can see a circle divides the plane on which it lies into 3 parts. They are inside the circle, which is called interior of the circle, and outside the circle, which is also called as exterior of the circle. We can say the circle and its interior make up the circular region. Here we can see the different terms of the circle, the radius, sector, segment, arc, tangent, chord, circumference and diameter of a circle. Angle subtended by a chord at a point. To know how can we see the angle made by a chord at a point, let us take a line segment PQ and a point R not on the line containing PQ. Now join the points PR and QR. We can see the line segment PQ and a point R not on the line and joining PR and RQ, we can see angle PRQ is called the angle subtended by the line PQ at the point R. Similarly, in the next figure, we can see angle POQ is the angle subtended by the chord PQ at the center O. Angle PRQ and angle PSQ are respectively the angles made by the chord PQ at the points R and S on the major arc and the minor arc PQ. Now, let us see some properties of the circle. Theorem 1. Equal chords of a circle subtend equal angles at the center. We are given a circle with center O and we are going to draw two chords AB and CD which are equal in length. We can say AOB is the angle subtended by the chord AB at the center and angle COD is the angle made by the chord CD at the center. We need to prove angle AOB is equal to angle COD. So we are given a circle with center O and the two chords AB equal to CD. To prove the angles made by these chords at the center are equal. That is, angle AOB is equal to angle COD. For this, let us consider the two triangles, triangle AOB and triangle COD. We can see AB is equal to CD, which is already given in the theorem, and we can say AO is the radius, CO is also the radius. AO is equal to CO and BO is equal to DO, again radius. Therefore, triangle AOB is congruent to triangle COD using SSS criteria. Using CPCT, we can write angle AOB is equal to angle COD. Theorem 2. If the angles subtended by the chords of a circle at the center are equal, then prove that the chords are equal. We are given two angles, that is angle AOB made by the chord AB and angle COD made by the chord CD at the center are equal, and we need to prove the two chords AB and CD are equal in length. For this, we are given a circle with center O and angle AOB is equal to angle COD. To prove AB is equal to CD. Consider the two triangles, triangle AOB and triangle COD. We are given angle AOB is equal to angle COD. Second condition, AO is equal to CO, radius of the circle. BO is equal to DO, again radius of the circle. Using SAS congruence, we can write triangle AOB congruent to triangle COD. Therefore, AB is equal to CD using CPCT.